Hi, welcome all. In this video, we shall discuss about numerical methods for solving nonlinear equations. We have to discuss two such techniques. The first one is bisection method. Consider an equation f of x equal to 0. If f of x is quadratic or cubic, we have algebraic formula for finding the roots. For instance, if f of x is a quadratic function, we all know that x is given by formula x equal to minus b plus or minus root of b square minus 4ac divided by 2a. So that is very simple. In the case f of x is a polynomial of degree 2 or 3. But when f of x is a polynomial of higher degree, this process becomes really tough. Or when f of x is an expression containing transcendental functions like sine, exponential, logarithm, etc., algebraic methods are not available. So that is the problem of solving nonlinear equations. So numerical methods will help us. So we'll look into a very simple numerical method, namely bisection method. If the function f of x is continuous between a and b, between x equal to a and x equal to b, and the value of the function at a, that is f of a, and value of the function at b, f of b, are of opposite signs, then there exists at least one root between a and b. So this can be simply demonstrated graphically. Let us consider this as x-axis and this as some y-axis. Now you consider a function something like this. Consider 2 points, say x equals a and x equals b. Now at x is equal to a, the function y means f of x. So this is f of a, and here the function is negative. And you consider another point b. Now at that point the function f of b is positive. Okay, so we assumed that f of x is continuous between x equal to a and x equal to b. So it must be continuous, and f of a and f of b are of opposite signs. So in that case, since f of a and f of b are of opposite sign, it must pass from some negative to positive continuously. So there is no way it must pass through at least one point, and it must bisect the x-axis. It must cross x-axis. That means there will be at least one solution here. Okay, it need not be necessarily one solution. There can be even more than one solution. So we may see that your function may be something like this. Your a is here, you choose a is a here, and f of a is negative, and you choose b here, then f of b is positive. There can be more than one. This is 1, this is 2, this is 3. There are 3 roots in between a and b, but it is very clear that there is at least one root. Okay, for definiteness, let f of a is negative as shown in figure and f of b is positive. Then bisection method proceeds like this. We calculate the midpoint of the interval a to b. So we find the midpoint of the interval. After finding the midpoint of the interval, we evaluate the function at that point. So if function at the midpoint is 0, obviously we get the real root. X is the root. And if f of x is less than 0, means f of x is negative. So you can replace the lower limit, that is a, with the x. So your interval bisects. And if f of x is greater than 0, then the root is between a and x. Then we replace the upper limit with b. Then we repeat the step from 1 to 5 until your f of x is approximately 0, or if your f of x is equal to 0. Okay. Okay, let us illustrate the process graphically. X, f of x, say your function is something like this. So we start at this point, x equals a. We calculate f of a. So it turns out to be negative. Then we consider some point b here. Now we evaluate the function f of b. It is positive. So this is our beginning. Now what we do is we find the midpoint. That's the first step. That means we calculate x equals some a plus b by 2. So it will be somewhere here, correct? Midpoint of line segment AB is this one. So this is my midpoint. Now let me call it as x. I calculated x. Now I evaluate the function. So when I evaluate the function f of x, it happens to be negative. Okay, so it implies that the root is between x and b. So if f of x is less than 0, that is negative, it simply means that the root of the function is between x and b. Okay, so our previous interval AB was this. Now you can make the interval half by choosing this one. Okay, so that means you are going to replace your a with x. So this is our new a. So let me call it as some a1 and b1, which is equal to b, and a1 equal to x. Okay, now we repeat the same step. For that, what we do is we consider this interval. Then what we do is we just find the midpoint of this interval a1 b1. So you can call it as this one. So somewhere here. Now what we do is we evaluate the function at this point. Okay, so when we evaluate the point, we'll get somewhere here. So this is positive. So the function is positive. So what does mean? If function evaluated at the midpoint is positive, that is greater than 0, it means that the root is in this interval, correct? In that case, your new interval can be chosen as a2 b2. What is b2? b2 is equal to the midpoint x. Okay, since if positive, then we replace the upper limit. So we proceed like this. We again calculate the midpoint of this interval. Okay, so we then calculate the midpoint of this interval. It will be somewhere here. Okay, then we evaluate the function. So that turns out to be negative. So what we do is we replace the interval like this. Okay, we replace the lower limit. Now the interval is something like this. Again we calculate the midpoint. So somewhere here. Then we evaluate the function. So that will be positive. Then we proceed. As we proceed, you can see that your interval becomes small and small and small. That means if you infinitely proceed this thing, your midpoint will be will approach us to the real solution, this one. So this is how bisection method achieves result. Hope it is very clear. So please remember that the function must be continuous in this interval, as well as the function evaluated at the lower limit and upper limit must be of opposite sign. Then only this method will work. As an example, we will consider a simple function. In order to solve x square minus 4 is equal to 0, we doesn't require any bisection method. However, just to illustrate the process, we will choose such a simple function. We all know that the solution is x is equal to plus 2 or minus 2. Okay. Now, to begin with, we choose some limits of the interval. Initially, we choose x is equal to 0 and 3. Means we choose a is equal to 0 and b is equal to 3. So when x is equal to 0, you will get minus 4. The function is negative. And at b, that is 3 square minus 4 will be 5, that is positive. So we have chosen such a condition. Then we calculate the midpoint. Obviously, the midpoint of the interval 0, 3 is 1.5. Then we evaluate the function at 1.5. So x square, 1.5 square, that is 2.25. Minus 4, you will get negative 1.75. Since this is negative, we replace the lower limit. So our interval, before it was 0 to 3, now it is 1.5 to 3. You can see that the size of the interval bisected, and that is why the name bisection method. Again, we evaluate the midpoint. We evaluate the function at the midpoint. It turns out to be positive, then we replace b. So that this interval reduces to 1.5, that is a, that remains the same. The upper limit b is replaced with 2.25. So again we calculate the midpoint. We find the function. It turns out to be negative. We replace a. So we proceed like this, and you can see that in the third iteration, f of x turns out to be 0.0625. Then f of x is very much closer to 0. Correct? Now it's very much closer to 0. You can see that f of x approaches to 0. 1.75, 1.06, negative 0.48. Now the distance to the root is negative, 0.25. So we proceed like this. We will approach the midpoint to 2, and at some point we will see that f of x is much closer to 0, and at that point we stop the iteration. So this is how we calculate the root of nonlinear equations. But this is the one point you have to remember is, to solve quadratic equation we doesn't require such techniques. But if it is some sine square x minus 2 log plus cos x equal to 0, it is not possible to find the root algebraically. So that is the usefulness of bisection method. Okay. We shall write code, Python code, for evaluating the root using bisection method. So we first define a function. So whatever function you use, you can write it here. Okay. So f of x, we define f of x. So you must rewrite it according to the function we choose. So the given, we just consider a simple function x square minus 4 equal to 0. So x square minus 4 is equal to 0. So one point you have to remember is, your function must be always, your equation must be always like f of x equal to 0. Now we do the same step. A is equal to 0 and b is equal to 3. Okay. So we have already explained that at a is equal to 0, x is equal to 0, the function is negative, and at x is equal to 3, the function is positive. Now the algorithm is like this. So the first step of the algorithm is evaluate the midpoint. Then you calculate or evaluate the function at the midpoint. So that is the first step. So we evaluated, and the function is stored in y. Now in order to see what it is, we just print the result, but this is not actually required. Now there are different possibilities. Your f of x, that is y, can be 0. What does it mean? X is the root. Okay, so if that is the case, means if y is equal to 0, we just print the exact root of the given equation as x, and we break the loop. Okay, with that you can stop the iteration. Now if that is not the case, there is one more possibility, that the root is very near to the real root. Your midpoint is much closer to the real root. So for instance, your y is 0.00001 less than 0.000001 unit away from your real root. So in that case, your iteration can be stopped. We doesn't require that much accuracy. Your f of x is much closer to 0. So you can decide how much closer closer to 0. So let me choose this much closeness. So if your f of x is this much closer to 0, you can stop the iteration and you can give the result as approximate root of the given equation as x. So if these are the cases, you can stop the iteration and you can exit the loop. So you please note that my loop while true is an infinite loop. So what I have done is I just evaluated the midpoint, then I evaluated the function at the midpoint, then I checked whether it is 0 or much closer to 0. If it is 0, I just got the solution and I print the result and break the loop. Else, if the result is much closer to 0, again I can stop the iteration and I break the loop. If these are not the cases, still there are other possibilities. Y can be less than 0 or y can be greater than 0. If y is less than 0 means you have to replace the lower limit a. So we write a is equal to x. If that is not the case, only remaining possibility is y is greater than 0. So if y is greater than 0, you just replace b with x. So this loop will execute indefinitely or infinitely as long as either this condition or this condition is satisfied. So as long as these two conditions are false, the loop will continue. So this is how it works. So this print function is to see how the loop proceed. So let us see the result. So the result is like this. So it in the next step, in the first step it was 0 and 3, the midpoint is 1.5, the function is evaluated negative 1.75. So this way it proceed. Then in the next step the midpoint is this, in the next step this is the midpoint, so on and so forth. They calculated the midpoint and you can see that it shuttles between 2. At the end you can see that it approaches to 2. We know that the real exact root is 2. Okay. Now you must appreciate this thing. Okay. Now let us check the same code by choosing a different value for b, say 4. In the first step itself, it evaluates the midpoint as 2, and when it evaluates the function at midpoint, it turns out to be 0 and we'll get the exact root. Okay, we'll see the result. So in the very first step, the midpoint is 2 and the function f of x, that is y, is 0, and we got the exact root of the equation as 2. So one important drawback of this particular method is this: it depends it depends the selection of a and b. Okay, the performance of the method depends on the selection of a and b. So you have just seen that when we choose b as 3, we obtained 2.00 something like that, while when it's 4 in the very first step we obtained the result. So it is highly sensitive to the initial point. Okay. Suppose you wish to find out the root of a particular another equation. Say the equation is something like this: some sin x, sine of x is equal to 1. That means sin x is equal to sin x minus 1 is equal to 0. So in that case you must write like this. But please note that core Python cannot evaluate sin of x. So for that you have to import either numpy or math. So we must import this. So let us import sin function from, or we'll use the standard way, import numpy as np, then you can call sine function as np dot sine. So this will do. Now we shall see. Okay, please try different equations, both transcendental equations, polynomial of higher degrees, etc. One point you must be careful about is selection of a and b. So you must choose a such that the function is negative at x is equal to a, and you must choose b such that your function is positive at x equal to b. So this is the only condition, and I request you to copy the code. I shall share the code in Moodle, and I request you to copy the code and change these functions and try to get the solutions. Thank you.